I had asked you guys to try and make a sine function out of this. So like I said, I asked you to make a sine function out of this. Now, I'm going to let you in on a little secret. Technically, that was an unfair question. First off, our sine functions are measured in degrees. This is measured in seconds. Second of all, some of you may have noticed this. I'm very happy if you did. Many of you maybe got confused with the h. If you guys remember, a sine function, technically, let's assume that this is just an amplitude of 1 for right now, takes till 180 to come back down. So what has happened here is this period has changed by quite a bit. But that is unfair because I have not taught you what number, to change a period. I'll give you a little heads up that technically there's a letter B in here. But we just assume B is 1 for our case. You don't have to know that for your test. I just wanted you guys to get thinking a little. So really the only two movements that you knew how to do were a movement of K up the y-axis and the change in the amplitude. So what I was looking for was a number for A and a number for K. Okay? We assumed our H was the exact same because it did go up just like a normal sine wave does from 0. It did go up and then come down and then go up and come down. Okay? So, let's just talk about those two movements for now. First off, what is the amplitude of a normal sine wave? Okay, let's get this together. Of our normal sine wave, we're going to call it f at x is equal to sine x. Okay? Our A in this case is normally 1. Okay, so the amplitude is 1. What was our new amplitude? 10. So, what should our new A have become? 10. Very good. Oh, there goes that. That's okay. So H at 10. I told you to make a sine function, so you would have written sine in there. Now, I know this is where many of you got confused with the H. Technically, we have no movement on the H. The period would have confused you. The only other letter I was looking for was K. K is normally, on our original sine function, anyone know? 0. We start on 0 on the y-axis. That's where our equation of the axis is normally on a sine function, guys. Normally our equation of the axis is right on 0. Where is our new equation of the axis? 12. So our new K is, very good. I want an equation to look like this. Okay? 10 is because our new amplitude was 10. Our old amplitude is normally 1. So you may encounter a question similar to this. May ask you to graph one of the ratios. In this instance, I'm going to do sine because you guys are very used to sine. Might say something different. Anyone know what other ratios it could say? Cos. Any others? Okay. You know how to find those on your calculator? Good. I'm going to show you how to do this with sine. This is asking you to graph a sine wave between negative 450 degrees and 450 degrees. Assuming we have never graphed a sine wave before, we're going to go by our x and y coordinates. So, sine x. I've looked at my graph. I have 0, 90, 27, 450. When sine x is 0, y equals 0. Pretty simple. Okay? Let's take another coordinate, 90. When sine x is 90, y is 1. Okay? Another coordinate I have, sine x is 270. Y is -1. And when it is 450, sine 450, we're back at 1 again. So I'm going to, these are all coordinates. I just put down 1, 2, 3, 4 different sets of coordinates. So I'm going to plot them. I know 0 is 0. When sine x is 90, we're at 1. When sine x is 270, I'm at -1. And at 450, I'm at 1 again. Okay, that's a bit arbitrary. There's quite a big jump in there. I'm going to try some of the coordinates in between and behind, actually. So I'm going to try for, what would this point be? 180. Let's try 180. When sine x is 180, hey, we're at 0. And what's another coordinate we missed? Yeah. When sine x is 360, 0 again. Hey, okay. So I put a couple more coordinates in there. And now I know you're all used to sine x, so you're able to figure that out easily. Here would be our 360. I have a wave that roughly looks like this. Okay? But they've asked us to go from -450. So I'm going to try -90. Sine is -90. What am I at? -1. What about let's go to the point in between. -180. What's -180 going to be? Anyone know? Back at 0 again. Okay. Now I put in some pretty even points. You notice all my y's are either -1, 1, 0. And looking at this wave, I can probably deduce what it's going to look like by just following the pattern. So I've drawn a sine wave. None of this is new to you. I know you know how to do this. I just want to enlighten you. If this was different, I want you to think about what you would do. I'm not going to tell you. I'm not going to take any questions about it. I want you to think about what you would put in the calculator if you were asked to find out what a wave was for a different function. Do you guys understand what I'm asking you? Yeah. Okay.
So can everyone make sure you bring a scientific calculator?
You have to have a scientific calculator tomorrow. Think about this. Think about if sine was a different ratio, and I know you guys know at least 2 other ones. Technically, there's another 5, but if I ask you for one of the other ones on your calculator, how you'd go about graphing it, and I might even ask you to shift it a little, using the prior knowledge we've had with sine, a, h, and k, how would you shift that function? These are review questions. Apparently, they're not in your textbook. So text page 378, numbers 1, 2, 6, 7, and 9. That's one question from each lesson. If you get stuck on one of them, do the questions in between. For instance, if you get stuck on question 2, try question 3. If you can't do that, try 4, try 5. They're all from the same lesson. 7 and 8 from the same lesson, and 9 on are all from the same lesson. Anything from 9 on are encompassing questions. They cover the entire chapter, so they may be good to try also. Do you guys have any questions?